Alright, I finished the speed control. So there it is. Off position right now. Everything's hooked up. There's no connections in the off position. So 1 is the lowest speed, 2 is higher, 3 is higher, 4, and 5 is straight to the motor. And the way this works is that each level has more resistance. 1 has the highest resistance. It goes through a bunch of resistive loops, so small wires. So I'll start off on level 1. So I'm using 12 volts and close to 10 amps at full speed. So I really do need some cooling. These wires are 20 gauge, very, very small wires. So what I'm going to do is I'm going to use this computer fan I found in the garbage, and I'm going to mount it right beside this while I'm using it. I'm only going to use it very short duty cycle, but what I'm doing is I'm turning all this electrical power into heat, so I don't want to burn these wires. So I'll be able to use this for the test, where I put the bowl on the stove and heat it up. As the battery voltage goes down, it's important that I can change the resistance so I can pump at about the same speed, and I just want a nice constant flow rate. I don't want to pump too fast. This is a speed control I made to control this 12 volt motor. You can really make the speed control for any power rating. It just depends on what wire you use and what resistance you want. I'm using this for this motor somewhere around 70 watts to 100 watts. So it's pulling maybe 6 amps at 12 volts. So I put this in. This motor was running way too fast and running my pump too fast, and to do some tests I just wanted to be able to restrict the speed. The problem with this speed control is it's a resistive speed control, so you lose some power. These coils become hot and it's using electrical power, turning it into heat instead of using it in the motor. So it's not efficient. If you're building a large electric car, you don't want to have something like this, because at lower speeds maybe more than half your power will be used just to heat up the coils. But for testing purposes it's very useful. I just use simple household materials to build this. Everything I used for this I had lying around. I didn't have to buy anything extra. First I'm going to show you how it works. So just on the dial here, off is in this position, then 1 is the first power. It has to go through all these coils before it goes to the motor. So if we're going to the motor over here in number 5 and the battery is hooked up here to the contact, we make contact here and it has to go through this coil, this coil, this coil, and this coil before it can go to the motor. So this is the lowest speed. Now speed 2 skips this coil. It has to go through 3 coils, so it's a little bit faster. Speed 3 only goes through these 2 coils. Speed 4 only goes through this coil, and then speed 5 is directly connected to the motor. It doesn't go through any coils. So it goes in from the battery, goes through 5, and goes directly to the motor. So that's full speed. So basically you get a very slow speed. In this application, the motor just barely runs at number 1. Number 2, it's running a little bit faster. Number 3, and then number 5, it seems like it's going to blow itself up. It's running like crazy. So that's how it works. Basically, you just have a dial and you have 5 speeds. With this, you can have as many speeds as you like. You have 1 less coils for your speed. So 1 is full speed, so you don't need a coil for that. So I have 5 different speeds and I need 4 coils. You can have 9 coils if you want 10 speeds, as many as you want. The next I'm going to show you how I built this. A little more depth of how this works. I was going to use, so basically you have a bunch of contacts that connect different circuits. And here you see this little piece of wire. This is just 20 gauge wire that I've stripped, and I just feed it through 2 holes. I feed it through one side and it goes about halfway up the other side. So it's pretty much just mechanically fixed in there. I haven't glued it or anything else. And when I rotate this, it comes in contact with one of these 5 contacts. So over here, I'm connecting to number 1. So what happens is electricity goes through here and then it connects to number 1, and then it has to go through all the coils and come out here. But if I connect to number 2 here, like this, then it can skip this one. It goes through here and it bypasses, goes straight to this coil, misses this coil. So that's what it does. In the first speed it goes through all the coils, every other speed it just misses the coils before it, and that's how you can change the circuit and change the resistance. For the bottom of it, so this is contact 1. It goes through here, goes through this coil, comes back. So basically just connecting wires and coiling the wire in between the two switches. So this has a coil here, and this has a coil here, and this is directly to the motor. So all I did was I took my 20 gauge wire, I stripped it, and I fed it in through a hole and came out the other hole to form this contact here. Again, it's just mechanical. I twisted the ends and then I soldered it together and I made my contacts in the back. So extremely easy. You don't need any glue, you don't need anything. You just need a drill and some wire. All I had was a lot of this. I had maybe 20 feet of 20 gauge wire. So it's just a single strand. It doesn't have a bunch of strands. You have to find the right wire for your application. It has to be a wire that gets hot and offers some resistance. So this wire is undersized to handle this much current. You need that in order to get the resistance. If you get a really thick wire, no matter how big your coil is, you're not going to get the resistance for your different speeds. So this is basically the materials I use. Some scrap wood, some wire, rock, everything else. So this is just a piece of 1x1 that I took, drilled a hole through the center, and then I drilled a hole through this piece of 3/8 plywood, which is the same piece as here. And then I just took this thick skewer and I cut off a section to make the pivot. So I just took a small section off the top, and that's what that is there. And that goes through to line up to hit all the contacts. Once you have this block with the skewer, and you have it sit in there, then you can just put a pencil there and make a circle to make, put a pencil here, rotate it to draw a circle. When you have your circle, you just divide it in the amount of contacts, and then you can drill your 2 sets of holes for each side to feed the wire in to make those contacts. It's important that you know that this the sliding contact or rotating contact is not too wide so that you don't bridge 2 contacts here. So this is quite a bit smaller. It would never bridge 1 and 2 at the same time. Once you leave 1, the motor stops, or you stop current until you hit 2. Also, it's good to lift it when you rotate it because there's a little bit of an edge here. It might get stuck. And for here, I just drilled the 2 holes. I stripped the wire a certain amount and fed it through the center. And then this doesn't work that well. I have a little loop here. This wire is pretty stiff, so sometimes when I pick a speed, it goes back by itself. It's a little springy, but you can like wedge it in there, and that's why I have the rocks. I have 2 sets of rocks here to put weight on the contact, to push the 2 contacts together, make a better circuit, and also to make it harder for it to snap back. When you're on setting 4, you have the most amount of current and it's only going through the first coil. So you don't have the extra resistance. So this coil has to be the beefiest. Then 4 is the next one. You can go down a gauge as you go down. These last 2, they don't handle as much current. So I just use like really thin alligator clips. And those have the multiple strands, so they can handle a lot less current. So I hooked my multimeter up, and I'm measuring ohms here. So it's about 1.8 ohms is number 1, the highest resistance. We move over to 2. We gotta wait for it to stabilize. 1.6, and we keep going. It keeps getting less. It just takes a while for it to stabilize, so it's hard to get all the readings. This one's even less, 1.2 or something like that. The readings I got before by waiting a little bit longer: 1 is 1.8, 2 is 1.5, 3 is 1.1, 4 is 1, and 5 is 0.8. So these are all the ohms. So 1 is the lowest speed because there's extra resistance. And then as you reduce the resistance, there's more current flow and you get higher motor speeds. So I'm a little concerned with the heat in these coils as I'm running this thing, so I want to have a good idea what kind of duty cycle I can do during testing. So I have my computer, the Arduino, and my thermocouples, and I'm going to measure the temperatures of 2 different coils. And as I'm running it, so 5 I'll use to prime to circulate the oil in the beginning. Then I'm going to run number 4, so I'm going to run through this coil. So this is the coil that receives the most current, and I'm going to run it for a couple seconds, and I'm going to graph to see how quickly the temperature increases, and then I should be able to find a limit temperature and limit time. And then I'm also going to measure here coil 2, so when I'm on setting 2, I'm going through this coil and this 3. This is the first coil that has the thinner alligator clip wire, so I also want to see that temperature. I just finished graphing what I just did, so I had 2 thermocouples in the 2 coils. This is a coil for speed 4, so speed 5 is just straight to the motor. So this has the highest amperage, but it's also the thickest gauge wire. So this coil, this is just running speed 4, so only coil 4 is heating up, and this is room temperature here, the blue. And then it let it cool down a little bit, and then I tried speed 2. So speed 2 uses a thinner coil and also uses coil 4. And you can see the thinner coil heats up even faster than 4 alone, which had a much higher current. And now coil 4 heats up slowly because there's less current when you have this those extra coils. So I ran this for just over a minute, and I got up to almost 100, 90 degrees Celsius. So that just shows me that it's very dangerous to run this for longer periods of time because I think it'll just keep heating up. So that'll be about my limit. I can only run it for about a minute. I'm thinking about taking this coil and replacing it with the same gauge wire, the thicker wire here, just so it really is a weak point in the design. But for my testing right now, I'm only going to limit myself to a 1-minute duty cycle. And other than that, the speed control works great. You just got to really pay attention to your duty cycle. You never want to turn it. If I put this on number 4 and I walked away, this would just keep heating up until it melted and shorted out and maybe caused a fire. So you really got to make sure you know what you're doing with the different currents and temperatures and different wires. And that's about it. So let me know if you have any questions about this design. I just thought it was amazing. I was looking for something like this. I was going to buy it, and I was just able to build it for free. So I wanted to share my experience.